Hi, welcome back. In this video, we're going to talk about congruent triangles. We're going to be focusing mainly on two types of theorems. The corresponding parts of congruent triangles are congruent theorems, also known as CPC-TC, and the third angles theorem. I'll explain what those two theorems mean. We'll do a few examples of each. We'll even do some examples from Schoology assignment, and then we'll call it a day. So here we have the corresponding parts of congruent triangles theorem, also known as CPC-TC. If you look at the first letter of each word, we're dealing with CPC-TC. Okay, and all this really says is that if two triangles are congruent, the corresponding parts, the sides and the angles of these two triangles should also be congruent. What does this mean? It means that if I have like angle K, for example, 78 degrees is the same as angle M, also 78 degrees. Angle L is 50, so angle Q is 50. Angle J is 52, so angle P is also 52. Notice how the sides, the corresponding sides, are also congruent, 50, 50, 39, and 39. So when you're writing down this congruent statement, you need to make sure that the order in which you write it down is correct. You cannot simply say triangle LJK is congruent to triangle PMQ. Because if you look at it, angle P or angle J would correspond with angle P. And J is 52 degrees and P is 52 degrees in this scenario. Sorry, I meant L. Here I'm saying that angle L corresponds with angle P. L is 50 and P is 52. Those do not correspond with each other. So the order in which we write this will matter, and it's really important that we write it in the correct order. So I'm going to start the first triangle by just classifying it as triangle LKJ, or writing it as LJK. As I write the second triangle, I need to make sure that the corresponding sides and the angles go in the same order. So L is 50 degrees. That means that it corresponds with Q. So I need to put the letter Q first. Similarly, J, 52 degrees, corresponds with P. So I would put P next. And then lastly, angle K, 78, corresponds with M because it's also 78. Notice how the angles go with each other, but also the segments. The first two letters, LJ, I'm going to label it over here in red. LJ is this side. Should correspond with the first two letters, QP. Notice how both of those segments are also congruent. So the sides are congruent, the angles are congruent, everything about them is the same. LJ equals QP, JK equals PM, even the first and last letter, LK, should be equal to QM. So now we use this information, right, to solve for some missing variables. So here I'm looking for the value of x and y. I'm first going to be solving for the value of y because I know that these two have one arch. So because B and D have one arch, I can say that these two are congruent. So y equals 48. So one arch just tells me that y equals 48 degrees. Okay, now similarly, because here we have two arches, this would equal the same to each other, 108 degrees. Now this piece is 48, and the other side is 108. Now I can solve for the value of f for this angle over here, because this whole triangle, I'm going to highlight it real quick. Now I know the measures of the triangle, and we know from the previous video, interior angle sum theorem says that all the angles inside of a triangle add up to 180. Okay, so we can set up the problem like this. I'll put this one in black. We can say 48 degrees plus 108 degrees plus this piece, 2x minus y, should equal 180 degrees. Now, I know what x is now. Sorry, I don't know what x is. I know what y is from our previous answer. So I'm going to plug it in there. I have 48 plus 108 plus 2x minus 48 equals, let's see if it, give me 1 second. I have 48 degrees plus 108 degrees. This is glitching a little bit. Plus 2x minus 48 should equal 180. Now, as I start combining like terms, I'm going to combine this one, and this one. I'm going to be left with 108 degrees. So I have 2x plus 108 equals 180. Now I can solve for x. I can subtract 108 on both sides. X equals 180 minus 108 is 72 degrees. When you divide both sides by 2, you get x equals 36. So here we have the value of y, we have the value of x, and we're able to use that by identifying which angles correspond with each other. Since these two were the same as these two, I can now add them all up to 180 and solve for the missing variable. The third angles theorem could be used for the previous problem as well. What this third angles theorem says is this. If I already know two angles of the triangles are congruent, I can assume that the third missing angle, angle A and angle L, are also congruent. Why are we able to assume that? Well, let's just assume, or let's say here we have this is 50 degrees and this is 60 degrees. If we were trying to find this missing angle, angle A or angle L, we would have to add them up and subtract it from 180. So 50 plus 60 is 110, which means we would have 70 left over. All triangles add up to 180 degrees. So if I already know two of them, right, and this is going to be left over as 70, this one should also have the same amount left over. They should both have an equal amount left over because they already share two of the same angles. So the third angle by default is also the same. That's why it's called the third angles theorem. If two angles are congruent, the third angle is automatically assumed to be the same as well. And that's what we can do here. I know that these two angles are the same. Angle N and L is congruent to R and S. So what can I assume of M and T? Right? Whatever angle is left over can also be assumed to be the same. So I'm going to copy this angle over here. And I'm going to label it as 2x plus 30. The third angle should also be congruent. Now here, what you can do, you can solve this problem in two different ways. You can add them all up, all the angles up to 180 for this triangle, right? Since we already have this third one. And I can say this is my equation. 55 plus 65. Plus 2x plus 30. I don't know what's happening here. Should all equal to 180. That could be like your basic theorem you can use for most every problem here dealing with triangles. All the angles add up to 180. I combine like terms, which are this one, and this one. I'm left with 2x plus, let's see, 120 is 150 equals 180. I can subtract the 150 to leave x alone. I'm left with 2x equals 30 degrees. Divide both sides by 30 to get rid of, I have no idea what's happening here. X equals 15. My iPad is glitching for some reason. And that's how you can find it. The alternative way is if I already know that these two angles add up to 120 degrees, what's going to be left over for this angle? Right? If these two is equal to 120, right, what's going to be left over here for this angle? That means that we have 60 degrees will equal for this last piece. That's equal to 60. So I can set up this equation as this instead. I can say angle M equals 60 degrees. So 2x plus 30 equals 60. And then I just solve. I subtract 30 on both sides. 2x equals 30. Divide both by 2. X equals 15. As you can see, it's less work than this problem. It's a lot shorter. You just have to do some mental math. These two add up to 120, subtract from 180, so this last leftover angle is 60 degrees. And then you set up a smaller equation than this one. Either way, they both work as a solution. So I hope this has helped you. If this video helped you in any way, please click the like button. It lets me know that it was useful for you. If you have any questions, comment below. If you haven't subscribed, I don't know what you're waiting for. And as always, we'll calculate later.